This is what I'm working on. This won't be a restoration, this will be a daily driver. Like me, it's too far gone to do much to. Today I'll show you what I did to repair the sending unit. Since this won't be a restoration, I decided to cut a panel in the floor of this bus to try to get that fuel tank sending unit out. And I had to guess, and I guessed fairly close because I could still get it out. But I measured this so you could be a lot more accurate than I was. All you need is a 5-inch square hole. 36 inches in as shown here, and then 4 inches over will put you dead center over the fuel tank sending unit. I used a cut-off tool to cut this panel out. But if you're concerned about sparks, you could use one of these little body air saws sold at Harbor Freight. Of course, don't even think about using a plasma cutter. When I'm sure everything's okay, then I'll tack weld this panel back in with my MIG welder and then use a little Bondo. Before you tack weld this back in, if you're concerned about sparks, use a damp cloth over this, or use some fiberglass insulation without the paper backing. Put some tape over that sending unit hole after you remove it. And why this white wire turns to brown, I can't tell you. The white wire with the female terminal goes to the terminal on the gauge, and the brown wire is the ground wire, and it goes under one of the screws that holds the sending unit in. This tube goes over the sending unit, and a nut holds it at the bottom. And the tube protects the nichrome wire, but it also keeps the fuel sloshing in the tank from making the float bob up and down. The center hole is for the retaining nut, and the two outer holes are for fuel entry. This is what you need to do first before you cut a hole, before you go to a great deal of trouble. Be sure that the black wire shown here in the foreground has 12 volts. Using a test light, ground one end of your test light and take the probe and touch it against the terminal marked B here on the gauge. When you do that, the gauge should jump all the way over to full. If it does, then you know you have a wiring problem from this left terminal B to the sending unit at the tank. I found an additional problem where the wire had broken where it goes through the firewall back in the engine compartment for the gauge. It's a single wire, and it's just a couple of inches away to the left as you're looking at the engine from the main wiring harness. With the wire removed from terminal B here, ground that wire, then go back at the tank sending unit and check for continuity to ground. Then remove the ground from the wire and check to make sure the wire's not shorted to ground. Then you'll know your wire is okay. The black wire, front right, marked black, also marked plus, is the hot wire for the fuel gauge. The other terminal, the bare terminal, is for the brown wire that goes to the sending unit. This is called a constant voltage regulator, and I first encountered it back when I used to work for Ford. It's used on Ford vehicles, and it regulates the voltage to the gauge. When a test light is applied to this, the test light will flash, and it cuts the voltage to about 5 volts for the gauges. Now this is used on a regular Beetle, but I did not see one on a bus. This 71 bus uses constant 12 volts to the gauge. So if your vehicle has a flashing test light when applied to the gauge, then it has a constant voltage regulator, and it's usually screwed to the instrument cluster. When I pulled the sending unit out and took the protective tube off of it, the nichrome wire was broken. I used my micrometer, and it did mic at 3 thousandths, and I was very careful not to put much pressure on it. You don't want to flatten that wire and get a false reading. And here is the sending unit without the tube, and I thought that you wouldn't be able to see the wires, but you can. Soldering the nichrome wire over this unit is a very delicate operation. I'm almost 75 now, but I still have a very steady hand. Both contacts where the nichrome wire is to be soldered to have holes, but it's very hard to desolder that without a desoldering tool to make sure that the hole is open. If you heat those contacts up and then tap it or shake it, you'll be able to shake the solder out of those holes on the contacts. Put your wire through the hole and tie just a half knot to hold it in place. The contact you see here supported by a piece of paint stick is spring-loaded so as to keep the nichrome wire tight. One end of the wire is soldered where you see the left red arrow, and the other end is soldered to the terminal on the sending unit where the right arrow is. Then I found another problem. That spring-loaded contact is supposed to be grounded to the sending unit body, and it wasn't. So I had to make a separate ground wire for it. And it is the blue wire soldered where the yellow arrow is. At the very corner of that spring-loaded brass strip that you see here in the photo, I took a very sharp awl and scratched an area clean around the edge of that contact strip so that the solder would take to it. It would be hard to clean that area with anything else. That worked great. Be sure that that wire is soldered securely. I had to resolder mine in order to get a good contact. Test it. Pull on it and make sure that it's solid. And I'm sure you know this, but I'll mention it anyway. Always use rosin core solder for electrical contacts. Acid core, of course, will cause corrosion. In this photo, you can see how the nichrome wire runs across the phenolic holder at the base of the main stud. What's so tricky about doing this is making sure that the wire stays where it should be while you make the solder connections. Solder one, of course, on one side and then do the other. And another photo showing that ledge that holds the wire. The threads, of course, are for the nut that holds the protective tube. It took several tries to get a real good photo of these contacts that are on the float. It's hard to see in this photo, but the left contact at the top turns over 90 degrees over that wire. The right contact is straight and just a little bit longer than the one on the left. The wire must go between the two. This photo is even better. With the float on its side, as you see here, at midpoint, lift the wire over the longer contact on the right and then carefully pull it back and let it catch under the 90-degree contact on the left. When you have it in the proper place as shown here, there will be spring tension against that wire, and the other side's exactly the same. So what that does, of course, is vary the resistance as the float goes up and down. You can check that resistance with an ohm meter as you slide the float up and down. Least resistance full, and more resistance, of course, when the float is down at the empty position. Float all the way in the full position, and this is made by VDO gauge. The cheapest I could find this sending unit was $110, so I fixed it for like $5. Another contact photo. That spring-loaded brass contact evidently lost its ground over years of corrosion. I mic'd an insulated wire and found a jet drill, the same thousandths, and drilled a hole through the side. It's a press fit, and then soldered it to the contact as you see here. Here is an optional way to ground that contact by using a single strand of copper wire, and it's not so thick as to keep the gasket from sealing. Be sure and use a flat washer over that wire so you don't cut it when you screw the screw in. Even though that wire is a press fit, I use some sealer on it. Here you see the float at mid position, and it does show half full on the gauge. Be sure and test this with an ohm meter before you put the tube on to be sure everything's okay. This protective tube can only go one way. This is an adjustable rheostat for ohms, and you can find these at Radio Shack and a lot of electronic stores, and they come in different ranges. I have several that are different ranges for different vehicles for different gauges, sending units. Suppose you used 4/1000 wire instead of 3. That thicker wire would have to have more resistance added to it. You could do that by using this rheostat to measure what ohms you would need to make the gauge read correctly, and then buy the proper ohms resistor and add it between your sending unit and the wire that goes to the sending unit. There is no way to decrease resistance. If the wire was too thin, then you'd be out of luck. There's nothing you could do but change to the right wire size. Adjustable rheostats like this are used to dim your house lighting. It's also used on most of the older shaft type radios for the volume control, TVs for the same volume control. When you have dialed in the resistance you're looking for, then you disconnect it, of course, and measure across these two terminals with your ohm meter, and then buy the proper resistor, and they're cheap and available at Radio Shack. I lucked out because the tank happened to be 1/2 full, exactly what I needed to make sure that the gauge is working correctly. This is the first sending unit that I have seen that works this way. Most of them have an arm with a contact that swings back and forth over a phenolic card, for the lack of a better word, and that card is wound with nichrome wire. Possibly those could be repaired too. I've never tried it. The way the regular VW Beetle sending unit is, it has that card wound with nichrome wire, and that's very similar to what Ford, Chevrolet, and other makes use. The good thing about being able to repair one of these sending units, especially when it comes to Ford or GM and other makes, in a lot of cases anymore you have to buy the tank complete with sending unit and the fuel pump, and that can become very expensive. Now this is the reading I ended up with, just very slightly below 1/2 tank, and that's good. I want it to actually show a little bit less than it actually has in it, so I'm happy with that. Now you can buy this wire, this nichrome wire, in many different thicknesses other than what you saw here. They come in thousands. Well, good luck with your repair. It's very tedious, but it saves a lot of money.